What is the equation of the horizontal asymptote of the graph of the following equation? F of x equals 4 to the x minus 1 power minus 10. Now, you should notice this is the graph of it, and just to save time, I'm not going to graph it on the calculator here because I already graphed it here, and to show you, and I did these in bars of 5 here. 10. We should see y equals negative 10 right here. That's the only one that would make sense. Y equals 4 is up here, positive 4. Y equals 0 would be here. Y equals negative 1. Y equals negative 10. That's the only one that makes sense. Plus, that's right there. The negative 10, that's going to be your horizontal asymptote. Okay? Easy smeezy. Okay, easy peasy, I should say. Let's go to question 30. We're really moving right along here. As x approaches negative infinity, which of the following describes the end behavior of negative x to the 7th plus b x cubed plus c? Now, the way I'm going to suggest to you to answer this is just plug something in for those constants and graph and see what it looks like. Now, I am going to pull up my calculator for this one. We turn it on here. Clear this. All right. Clear what I have here. Now, it says y equals, okay, negative x to the 7th plus b. Make it anything. I'll make it 2. X cubed. Doesn't matter what you make it. Cubed. Plus c. Plus some constant. Plus 3. Doesn't matter. You're just filling it in because it doesn't matter what these numbers are going to be because the graph itself is going to look similar. It'll just be fatter or smaller depending on whatever numbers you choose. All right, let's graph it. Okay, yeah, so your graph is going to look similar. So now we can check out the end behavior because it said which of the following describes the end behavior. So as x approaches negative infinity. So as x approaches negative infinity this way, y, or f of x, is approaching positive infinity, which is choice C. F of x approaches positive infinity. Okay? Yep, again, another so-called difficult question made simple. Let's go on to question 31. Now, Jessica paid $23,000 for her car and kept a record of its value. And here are the numbers here. Now you should notice in this chart, the x's are increasing, the y's are decreasing. And this is an exponential decay, as you know, because one's going up, one's going down. This is a decay. It says assuming the relationship is exponential, see it says exponential. It's either going to be exponential growth or exponential decay. Which equation best models the curve of best fit for the data? Now, you should remember from your lessons, exponential growth is whenever the number being raised to the exponent is 1 or greater, and exponential decay is when it's less than 1. Now, look at our first two answer choices. Both of these are greater than 1. Those are exponential growth, so they couldn't be our answer. But our last two choices are both less than 1. So one of these has to be our answer. Let's find out which one. If we start with the first one. So what I did was exponential growth or exponential decay. So I did 23,100 times 0.85 to the 1, which is just 0.885, and that gave me 19,635. And then I just tried x squared to the next one. So 23,100 times 85 to the squared gives me 16,889. Now our actual numbers are 20,000 and 16,000. So I got 19,600 and 16,600. Those are kind of close to modeling the data. So then I tried the second one, 23,500 times 70 to the x. So 23,500 times 7 to the 1, which was 16,450. That's a little different from 19,635. And 23,500 times 7 to the squared is 11,515. Now, those numbers are a little further away than the numbers for C. So C is the equation that best models this data. Again, now, you can go ahead and punch these in on your calculator. You'll get the same thing. I was just saving time by doing it beforehand. Okay, let's move on to question 32. Oh, this one causes students a lot of heartache. What is the sum of the infinite geometric series 9 minus 6 plus 4 minus 8/3 plus etc., etc., etc.? Now, this is an infinite series. Now, what we need is, it's an infinite series, infinite geometric series, so we need the formula. Now, if we look at our Algebra 2 formula sheet, which I just happen to have handy here, our Algebra 2 formula sheet. Now, if you're taking this test online, you're going to have a pull-down menu for the formula sheet. If you're taking the paper test, you'll have a paper formula sheet. Okay, so infinite. Now, this is infinity, the sum of infinity, geometric series, is this formula right here, which I copied. So let's go back here. The sum of the infinite geometric series formula, sum of the infinite series is a sub 1 divided by 1 minus r, and r is the common ratio, and the common ratio has to be less than 1 in order for there to be a sum. Okay, like I mentioned here, a sub 1 is the first term in a series, r is the common ratio. Now, to find the common ratio, you divide the second term by the first term, or the third term by the second term, or the fourth term by the third term. Now, I did it here, but I'm going to go ahead and do this on calculator for some. You want to find the common ratio. Let's clear this out here. So now, dividing the second term by the first term. The second term is negative 6. Divided by the first term, 9. Oh, excuse me. I was just drinking some soda. Okay, so that's negative 2/3. Now, just to double check, I can divide the third term by the second term. So 4 divided by negative 6. Negative 2/3. And then just to check for good measure, I divide the fourth term, by the third term. So fourth term is negative 8/3 divided by the third term of 4. So we see consistently that the common ratio between each of these steps is negative 2/3. Okay? So our ratio is negative 2/3, which is less than 1, so there is a sum to this series. So now let's apply the formula. The sum of the infinite series is equal to a sub 1 divided by 1 minus our ratio. So a sub 1, the first term in the series, is 9. So that's going to be 9 divided by 1 minus negative 2/3. So 9 divided by 1 minus negative 2/3 is basically 1 plus 2/3. So 9 divided by 1 plus 2/3. And I did this on calculator here. 9 divided by 1 plus 2/3. Matter of fact, I've got my calculator up. Let me just go ahead and do it here. So 9 divided by 1 plus, and I'm just going to place that in parentheses, 2/3. That gives me 5.4. Well, 5.4 is not one of my answer choices here, so let me convert that decimal to a fraction. So I hit math, 1, 27/5, which is choice C. Okay, so the sum is 27/5 for this particular infinite geometric series. All right, let's go. Number 33. Which number is a 0 of 7x squared plus 16x minus 48? Well, I would just factor this. Now, your teachers may have taught you different ways of factoring. I'm just going to go with what I feel is a simple way to factor. Now, when I teach my students how to factor, whenever there's a coefficient larger than 1 in front of the x squared, I tell them that the first two terms here are going to be factors of this coefficient. In this case, 7 and 1 are the only, so 7 and 1 are the only ones that will fit because that's a prime number. Now, I tell them the last two numbers here are going to be factors of this c term, which happen to be negative 48. Now, factors of 48 I've listed here. So, through guess and check, I found out that this factors to be x plus 4 times 7x minus 12, and then to double check, x times 7x is 7x squared, x times negative 12 is negative 12x, 4 times 7x is 28x, 28x minus 12x is positive 16x, positive 4 times negative 12 is a negative 48. So, this is the factoring of it. Now, if I set these equal to 0, I'll find out which one is a 0. So x plus 4 equals 0. I subtract 4 on both sides, x equals negative 4. Well, I don't see negative 4 in my answer choices, so let me go to the second one. 7x minus 12 equals 0. Add 12 to both sides, I get 7x equals 12. Divide by 7 both sides, x equals 12 sevenths. 12 sevenths is one of my answer choices, choice C. So that is the answer for this question. Oh, well, only 5 more questions to go. Woohoo! All right. Which function is the inverse of g of x equals x cubed plus 11? All right, this is an Algebra 1 concept that you should have down pat. If not, here's how you do it. So, g of x equals x cubed plus 11. First step in finding the inverse of a function, change g of x, f of x, h of x, whatever it is, to y. Y equals x cubed plus 11. Next step, switch the x and the y. So x equals y cubed plus 11. Now, you need to solve for y, and then you will have your inverse. So what I will do is I will subtract 11, both sides of the equation. If I do that, I get x minus 11 on the left side and y cubed by itself on the right side. Now, again, I want to solve for y, which means I need to get the y by itself. So I'm going to cube both sides of the equation, because the cube root of anything cubed is simply what's under the radical. So when I cube this side, that just leaves me with y. When I cube this side, it's the cubed root of x minus 11. Then, to put it into terms of inverse, g of negative 1, which just basically means the inverse of the function, is the cubed root of x minus 11, which happens to be answer choice A. Okay? Pretty simple. Now, let's go on question 35. Oh, we're almost done here. What is the domain of g of x equals log x minus 1? Simplest thing to do, just plug it in. Just plug it in. Let me clear this. Y equals, let me clear this out. So that says log. So you hit your log key, parentheses x minus 1. Graphic. All right, so domain. Domain basically means x values. Well, looks like your x values start at positive 1 and keep going. So x such that x is greater than 1. That's the only answer choice that makes sense. Choice C right here. Right? All right. That one's done. Question 36. All righty then. Let's see what we have here. A scientist obtained a sample that contained 80 grams of radioactive barium-122 that decays exponentially over time. The amount of barium-122 that remained in the sample at observed times is shown in the table. All right, let's see what we have. So, our x's are increasing, our y's are decreasing, so there is an exponential decay going on here. Now, let's see what it says. If the radioactive decay continues at the same rate, which is closest to the amount of the sample of barium-122 remaining at 5 minutes. So we have data here up to 4 minutes, so they want to know what's it going to be at 5 minutes. Okay, well, let me bring up my calculator here. step by step. This is how you do it. Let me clear this here. I want to go into my stat menu. I'm going to hit stat, edit. And here, the time, minutes, I'm going to enter that into my L1 because these are my X values. And then the mass of remaining barium, those are my Y values. So I already went ahead and pre-entered them, but you would just enter them if you were doing this from scratch. Now that I have my data in, now, again, I mentioned that this is exponential. Yeah, because it says it decays exponentially over time, exponential decay. So we need to find an exponential regression formula in order to answer this question. Now that I have my data in, I go to Stat, right arrow over to Calc, come down, option 0 is exponential regression. That's what we want. Now, our X list L1s for our X, L2 for our Y. Now, when we get to storage EQ, I don't want you to go on to calculate just yet. This is what I want you to do. Now, hopefully your teacher has shown you this next step. If not, you're learning it now. When you get to storage EQ, I want you to hit your vars key. I want you to right arrow over to Y vars, hit 1 for function, and hit 1 for Y1. And you see a Y1 pop up. Now, the reason why you're doing this is after the computer or the calculator calculates the function, the Y1, it's stored in here to pull up later on. Okay? Now that you have your Y1 showing, now I want you to calculate. So, your exponential regression formula is Y equals 80.02 times 0.707 to the exponential. And if I look at my R squared, my correlation coefficient, 0.9999999, so it's saying it's pretty much dead on. So that is my exponential regression formula. Now, I've saved that in Y1. Why? Because the question says, which is closest to the amount of the sample of barium 122 remaining at 5 minutes? So now I want to find out what 5 minutes are. Now, this is why I asked you to go to the vars. Hit your vars key, again, right arrow over to Y vars, hit 1 for function, and Y1 for Y1. So now, that function that we just saw is saved there in Y1. I want to know what Y1 equals when it's 5. So I put in parentheses 5. What is this function when it's at 5? And it's 14.14 is what we have here. Let's look at our answer choices. 14.1 grams, that is the closest. That matches, so choice D is what this is. Okay. Woo! 2 more questions to go. All right. What is the sum of the first 20 terms of the arithmetic sequence? So beforehand we used a geometric sequence. Now we're going to use an arithmetic sequence. 1/3, 2/3, 1, 4/3, 5. Now, just looking at this, you should see that the common difference between them is adding 1/3. Adding 1/3. Now, if I go to my formula sheet, my paper sheet here, or your pull-down menu, all right, so arithmetic sequence. All right, so we see it here, the sum, because sum of the arithmetic sequence is this formula here, which I've already copied. So sum of an arithmetic sequence formula, sum of the number is equal to the number divided by 2 times 2, a sub 1 plus the number minus 1 times d, the common difference. Common difference is 1/3. You should see here. So let's plug this in. Now it says the sum of the first 20 terms. So our n is 20. So s of 20 is equal to 20 over 2 plus 2 times the first term, which is 1/3, plus the number 20 minus 1 times the common difference of 1/3. Okay? 20 over 2 is just 10. 2 times 1/3 is just 2/3. 20 minus 1 is 19 times 1/3. Then we simplify 10 times 2/3. Now 19 times 1/3 is 19/3. Now 2/3 plus 19/3 is 21/3. So 10 times 21/3, that's just 7. 10 times 7 is 70. Our answer, choice C. Okay? Not that hard. Not that hard at all. Okay, and finally, oh, look at that. Last question. So, type your answer in the box. What is the number of possible permutations of 8 objects taken 3 at a time? And I was kind of quick. I'm just going to do this on my calculator here, because that's the quickest way to do it. Let me clear this out. So it says permutations of 8 objects taken 3 at a time. Where you do this on your calculator. So 8 objects, and we want permutations. Hit your math key. Scroll over to probability, and you see option 2 and PR. P is for permutation. 3 would be for combinations if they ask for combinations. But if they ask for permutation, we're going to select option 2. And then it says taken 3 at a time. 3. So 8 objects permutated 3 at a time is 336. There's your answer. Okay, people, so that is the spring 2015 item test set for the Algebra 2 SOL. So look at this video again if you need to, or several times if you need to, and it should help you to pass the SOL successfully. All right, good luck. Have a good day.